Hello, my name is David and I am a fourth year engineering student at Durham University, about to finish my summer placement with the Durham Energy Institute. Today I'll present my key findings from the literature review I have carried out in regards to the economics of hydrogen technology. To introduce things, with the UK's target of carbon neutrality by 2050, hydrogen provides an excellent method as both energy storage and as an energy source. Whilst the current installed hydrogen capacity is less than that of the heavy goods vehicle market alone, there is potential that as demand for hydrogen grows due to renewable intermittency, it can unlock larger UK markets. As it does this, costs should fall significantly. In terms of production, hydrogen production costs vary depending on the process used. Some of the cheapest hydrogen production costs in the UK are found from steam and plasma reforming. Typically using methane, the low cost of this can be associated with the current low price of hydrocarbons in general. This also explains the low cost of other hydrocarbon-based systems such as autothermal reforming and partial oxidation. In comparison, electrolysis-based methods such as wind and solar are somewhat expensive due to high capital costs and the fact they are determined by the price of renewable electricity. However, these are expected to fall in the near future. Thermochemical water splitting and thermolysis typically enjoys low operating costs, but high capital costs due to the need for corrosion and heat-resistant materials. Biological production methods, on the other hand, such as pyrolysis and gasification, are extremely promising in regards to cost, but often suffer from impracticalities such as the need for large-scale resources and long production times. In terms of storage, there are two main types, physical and materials-based. In physical-based systems, costs can stem from compression and material costs used in compressed gas systems. Whilst in cryogenic tanks, extreme cooling contributes to significant energy loss. For large-scale storage, salt caverns often have the cheapest cost per kilogram, at the price of extremely high investment costs. In materials-based systems, nanomaterials and metal hydrides require extreme temperatures or expensive catalysts to allow for an acceptable density of hydrogen storage. Liquid organic hydrogen carriers often have high costs from their synthesis and hydrogen conversion. Irreversible reactions mean that chemical hydrides need a constant supply of material, and chemical hydrogen often has similar cost issues to cryogenic hydrogen, albeit with the advantage of higher storage density. In terms of distribution prices of hydrogen vary depending on the method in which the distribution takes place. Liquid hydrogen-based tanker trucks are the most expensive out of all methods due to the extremely cold temperatures necessary for liquefaction. Their density, however, makes them the most appropriate for smaller market penetrations of around 1 to 10%. Whilst less dense, gas hydrogen tanker trailers are over 50% cheaper per kilogram than liquid hydrogen trailers due to the moderate temperatures and the lack of phase changes or conversions required. Whilst hydrogen gas pipelines have the lowest cost per kilogram, investment costs are extremely high. With greater market penetrations, the extra demand for hydrogen means that these high investment costs for greater distribution can become economically viable. In terms of competition, as the price of hydrogen falls, there are differences in the cost it has to fall for it to become competitive in different industries. It can be seen that a lower cost of hydrogen is required to power heavy goods vehicles than that for residential heat and power, in order for the cost to remain competitive. However, the industry and the transportation sector as a whole will maintain a large demand for hydrogen due to the following factors: the banning of petrol and diesel cars from the UK by 2035, the abundance of cheap natural gas, and significant increased and often necessary range and decreased charging time over other low-carbon technology. These market pressures mean that even if profit margins are somewhat reduced, the quantity of potential customers will remain high. So to conclude, there are a number of different technologies at varying costs for hydrogen production, distribution, and storage. The suitability of different technologies depends not only on the cost per kilogram of hydrogen, but on other factors such as investment costs and timescales. Cost of all technologies will fall as hydrogen production continues to increase due to the presence of renewable energy. Thank you very much for listening.